Hi guys, I have something here from a viewer, subscriber. Asked me if I'd have a look at this. So let's see what's in the box. Surprisingly heavy. It also contains some accessories, so let's have a look. Yeah, there's a charger in here, okay. And this is the device. So he's obviously dismantled this to some extent. And this is Bose. Yeah, so I don't have the covers for it. The speakers in here. A bit of a dent in there. Just show you, by the way, that was there when I received it, okay. So, yeah. Define plus 2. Bluetooth speakers, that's what we actually have. Okay. And I have a few, or at least one email relative to this, so let's have a look and see what the owner says about it. PCB, book converters I can see on here, that's the first thing I can see. This is a long shot. I have docking Define plus 2, PCB, does not charge the battery. Happy to have a look and potentially make a video. Happy to pay for the service, postage. So he's replaced the battery for a brand new original one. He's replaced the charger for a brand new original one. Check the charger is supplying enough voltage. Took out the PCB to inspect. There's no obvious burnt or damaged parts, no broken tracks. Check continuity, connect to the PCB. Check PCB receiving 15 volts from the charger, yes. Gone over all resistors, caps, diodes, inductors with a multimeter. Okay. Charging IC seems to be okay with correct voltages. We can have a look at that on the data sheet, I think. Okay, so the battery stays at the constant voltage no matter if I plug in the charger or not. However, the speaker does acknowledge the charging as the LED is blinking when plugged in. The speaker still works and sounds brilliant, so I don't want to throw it away. Only the charging not working. And then it just says some nice things. Thank you, Philip. Okay, so that's what we have. Let's have a look at the actual item ourselves, but just while I'm here, I was going to say this capacitor looks like it's kind of like bulged, but I think, to be quite honest, these type of capacitors look like that anyway quite often. But let's take a look ourselves. Okay, so this is the actual speaker. There was a bit of insulation tape on here. I've just taken them off. Actually, it was holding this top down. And Philip has given us some instructions. So it says battery, remove first. Screws, bottom plate, remove third. And then there's a remove second, obviously, somewhere. Drivers, remove second. So he gives us some information. Okay, let's try this. Okay, so I'm in. Just a few screws. Actually, the arrows were showing where the screws were. It was just a little bit difficult to see. Shine a torch down there. That's soon sorted that out. So this is our amplifier. This must be a Class D type amplifier because it's so small. Yeah, there's no heat sinks or anything on it. All the weight is in these speakers. These things on the back, which kind of look like oval speakers, are kind of like resonators. So these are like a dummy speaker, if you like. It must help the bass response. Sometimes you'll find loudspeakers that look exactly like loudspeakers, but there's no coil on them to do the same thing. Okay. And here's our PCB. So, yeah, that's off. This connector is going to the ports on the back of here, USB, charger, okay. And this is what we have. So this Bluetooth, I'm guessing, it looks like a kind of a Wi-Fi type adapter, something like that. Sure, this is a Bluetooth thing. This looks like a VRM controller of some sort. Let's have a look. I'm just having a look around at the moment, guys, just to see. What do I see? Well, I see these coils connecting to these. These are your speakers. These are inductors, yeah. These are not like buck converters. This is a Class D amplifier, okay. And it looks like it's driving each speaker individually. So like a half bridge type circuit, or maybe actually probably a full bridge. So it effectively doesn't have one end of the speaker connecting to ground, it's driving both ends. That's what I think we have. So those are close to this, and they come back to this, and there's capacitors here. So this must be the amplifier chip, okay? We can look it up, TPA3118. But it says the audio is working, so I pretty much can assume that's okay. This looks just slightly suspicious, but I'm not totally suspicious of it with this type of capacitor, okay? And again, that appears to be part of the amplifier circuit anyway. This is your power in. So this comes from the battery. This is your battery, okay? Plugs into there. This looks like a buck converter to me, generating a lower voltage rail. This looks like another buck converter. Possibly these are generating a plus and minus supply. Not totally sure yet, but you know we work this out, guys. A little bit of gunge or something on here. Yeah, it's just a bit of glue, I think. Nuvoton chip, got a part number. And this one. This can be part of the power supply or the battery charger. Again, we can look up the part number. What else do we have here? This one, 4409 BPS 134. So I think what we'll do is with this first, we'll make a note of all the chips. So I'll write down all the chips, just draw a rough layout of the board and where they are. And then let's find data sheets and see what we have. And that will give us a very good idea of how this actually works, I think. Okay. So let's do it this way for a change. So what do we have? We have a connector here. This goes to the USB. There's a jack socket here. There's a power socket here. So this connector here, this is power from the charger. It's got a jack. It's got USB. So they're all sort of coming in into here. Okay, we know that much. Now, we have a couple of large capacitors here. And quite a big chip. We have another big capacitor, a smaller one. And the more I look at these, the more suspicious I actually am of them, to be quite honest. We have some sort of inductor here. So I'll put L on it. C, these are capacitors. I, C. So we sort of know what we have, yeah? C capacitor. And here, next to this coil, is what looks like probably a buck controller. IC, okay, and then the other side we have an 8-pin IC. So that's an 8-pin chip. Okay, IC. So that's sort of what we have there. This is your battery. So I'm assuming that is for the charger. Charger power there. And this is battery, okay. And this kind of comes into this lot and this lot. So here, battery. What else do we have? Well, this looks like another buck converter. We can see the inductor. There's a little chip by there. That's capacitors again. So we have that's down here. This is not to scale, obviously. We have another inductor, L. We have another, this is a 6-pin chip. Okay. And we have a couple of capacitors. So C, that's an IC. Can't write in it, but it's an IC. Okay, so we have that. We have then another IC here. Okay, and then we have the connectors to the speakers. So these are your speakers, I'm assuming probably left and right channel. There, okay, you see them, speakers. What else do we have? We have another couple of capacitors here with a inductor, LCC. So this looks like another power supply. There's another 6-pin device there. That's probably the equivalent of that. So that's probably the driver. 1, 2, 3, 4, 5, 6. Okay. We have a row of 4 inductors here. So 1, 2, 3, 4. And we can see that these are connecting to the speakers and they're connecting to this. So these connect like so. So I think we've got a good idea what they are for. That's the audio outputs. Okay. We've got another IC. Okay, so there's another chip kind of here. IC. Now come across. So this looks like some sort of Wi-Fi or Bluetooth thing there. Okay. We have another little 6-pin here. Okay. So I'm just literally just kind of like drawing what I see. This is another multi-pin thing here. Okay, this is the crystal. So this could be a processor or something, or this could be. And again, we have another in the corner, another inductor, and we have a chip kind of here. Okay. So that's basically what we have. Oh, we have one more chip there as well, so we'll put that one on. That's sort of, this is obviously nowhere near to scale, but that's kind of here somewhere. I see. Okay, 1, 2, 3, 4. So we know what we have laying out here. So what I'll do now is have a look at all the data sheets for this and find out the part numbers of these ICs. Then we'll look them up and then we'll make a note of what these things basically are. Okay. And that gives a good idea of the function of the whole thing. Even without looking up the data sheets, I can pretty much say this is some sort of power supply. This is another power supply. This is probably higher current than this one, bigger capacitors, bigger coil. This is another sort of power supply, same sort of power as that one. This, another inductor, probably another power supply here. Okay. Right, let's see. Okay, so I have the microscope. We'll start in the top left-hand corner. We have a chip here. So this one we can see is HT7178, also marked BA2703. It looks like, yeah, in fact it does, even more than looks like. This is connecting from the chip here on 3 pins to this inductor, so this is almost certainly a voltage rail, and this is some sort of buck converter. Okay, probably this capacitor's on the input, this one's on the output. That's how it looks like to me, just from the layout of the board. Okay, so that gives us some idea, but we can look up the part number on that one and we can have a look, see what's this for sure, for completeness. This one, BPS 134. Oh, this, I'm pretty certain again I know what this is. So if you look, we have the output from this buck converter goes to 4 pins on here. Then we have 3 pins and 1. So there's effectively 3 connections on this. This is a MOSFET, so this is the gate, and this will be switching the power on to other parts of the circuit. Hopefully you can see that, but we'll look up the part number anyway. Depending on your skill level, you may or may not recognize that for what it is. For me, I think it's just experience. Okay, so down here we have this tiny little thing. This is marked with an SMD code. I can read it NYBTC or NY8TC. These might be harder to find, so I'm not going to look that one up right now, but I can see what it is again. So similar to the one we were looking at before, we have a capacitor here and a capacitor here, probably input and output, and you can see that the middle pin of this one goes to this end of this coil. The other end of the coil, yeah, it says 5 volts here, and that comes to here. So we can say this is a 5 volt supply, this is a test point, and we know this is a buck converter. So if we have 5 volts coming out, I really don't need to look that up. If we don't, then we have to figure it out. Actually, did we see a voltage up on the other one? I didn't really look. No voltage mentioned on that one. Okay. So down in this area we have this chip, AD3705. I don't know what that's doing. It seems to connect into this slot somewhere, and then into it doesn't go to the speakers. So okay, we'll look that up and find out what that is. What else do we have? This one. 9C4RY1. I think it's probably the bottom number, PA3118. So let's make a note of that. PA, power, oh, TPA. Texas power amplifier. You see a Texas logo on it, so we know who made this thing. So we were pretty sure, because look where it goes to these 4 coils and then down here to the speaker connectors, we pretty much know that's the amplifier. Okay, and we can look it up. For some more. While we have this thing in the middle, NPCA110B. Yeah, that's that one. I'm just looking around this. This is the one with the oscillator chip byte. Thought this may be some sort of microcontroller because it has the oscillator byte, so you think that's probably what it is, something like that. Again, that's just kind of a bit of experience for me, really, I guess. What else do we have? This one. So this is near the middle of the board. Okay, this one, N76. Let's make a note of this. 003A. T20. Not really sure what that one is, to be quite honest, at the moment, but we have it. Top edge, this one. This is another MOSFET. Remember that other one we had? So this is this BPS something or other, same. 4409. You can see again we have effectively a gate, source and drain in there. So that's a MOSFET. That's controlled, well, the gate sort of comes this way somewhere, okay. We have another inductor in the top corner, we were looking at that one, so we have a chip byte. Does this go to the inductor coil? Looks like it, so it looks like these 2 pins go into the coil. So I suspect this is another buck converter of some sort, generating a voltage rail, probably some low voltage for the CPU. So FP8207. It's near to that thing that looks like a CPU, so I think that's what it probably is doing. Okay. 2 capacitors by it, probably one on the input, one on the output. Another one in here somewhere. 9827. I don't see any coils around this, but I wouldn't be surprised if it's a linear voltage regulator. That's that. Well, it could be something like an AND gate. 9A27. Let's make a note of that. And there's one more. That one. Again, this we can see clearly. One pin goes directly to this coil, so this is another buck converter. Okay. Right, let's look up the data sheets for the ones we can see part numbers. So HT7178, I think he's actually said this is a boost converter, similar to a buck converter. It just generates a higher voltage output rather than in, but this is what we basically have. It's all in Chinese. This one's a bit hard to see, but we can see this is the coil here, for example. So we have voltage in, a coil into the switch, and a voltage out. So the fact the coil is on the input side tells me this is a boost converter. So this is generating a voltage higher than the input voltage. The 4409s, which we looked at how they were laid out, and I said these are MOSFETs just from how they were on the board. They are in fact MOSFETs. So we have that right, they're P-channel MOSFETs. AD3705, I can't actually find an exact data sheet for this, but I think it is an analog to digital converter. Probably in this series, I just couldn't find the exact one. It says for 3705, but when I click on one of these, I get something slightly different, okay? But I'm fairly confident because we know what this is, that is an analog to digital converter. It makes sense. TPA 3118. So this is the amplifier, Class D stereo amplifier. That's what we basically figured it was just by the way it was connected on the board with the inductors. So this is the chip, look, LC filter, that is the inductors which go to the speakers. We can see the voltage it runs at, but we do know the amplifier actually works. This one, FP8207, this is the battery charger, so 18 volt 3 amp multi-cell battery switching charger. So we now know where the battery charger is. We can see a typical application. So this will help us with this. We'll be able to see if it gets power from the adapter, what's coming out of it, and specifically whether or not it is enabled. So in this typical application, EN is just connected to power in, so it just automatically enables. Ours may not do. It may be enabled by the microprocessor, but that will help a great deal. NPCA110B. This, although I thought maybe the CPU, look, audio enhancing engine with codec. So this is the audio processor, basically. Okay. This one is the CPU. So the N76E003, you can see it tells us is a 8051 based microcontroller. So that is an 8-bit microcontroller, and that is effectively the brains of this item. This is probably what's controlling the battery charging, switching that FP8207. Okay, so we have that. The other little things, well, there were SMD codes, but we know they are in actual fact buck converters because they wire to the inductors. So let's put this on our page now and we'll know what we have. And here we have basically what we need to know about this device. We pretty much know everything about this PCB now, at least from the point of view of diagnosing the fault. So boost converter generates a higher voltage on the inductor. MOSFET looks like it switches that voltage on, controlled almost certainly by this, directly or indirectly. We know this is a P-channel MOSFET, so we have effectively 0 or ground on the gate to switch it on. rather than a positive voltage, so we can pretty much know if that's working or not. We have some sort of buck converter. So this is a voltage rail. Again, we can measure it on the inductor. This, we're not sure, but it's probably an A to D converter, analog to digital, which would make some sense because of the application. This one, again, is a buck converter. We can measure the voltage on the inductor. There should be some voltage. We don't know what it is, but if we do have a voltage, it'll probably be something sensible, like 3.3 or 1.8, or, you know, some other voltage you would expect. So we'd have a good idea if that's okay or not. This one, I couldn't find a SMD code. I think it's probably a voltage regulator, but I'm not sure at the moment we need to worry about it. This one here, MPCA110B, is the audio codec, the audio processor. This one is the CPU, or rather microcontroller. This is the battery charge controller, and there's another MOSFET here which is probably involved in that, actually, to be quite honest. So in the same way that these probably form a circuit, I think we can say there's a high likelihood that those form a circuit. So that is a good way to start if you have a PCB that you may know what the application is, but you don't really understand what you have on the board. Spend a bit of time to do this and then see what you've got. And I hope you agree with me that it didn't take much work to get that. Anybody could do that, really. Okay, I knew a little bit about how to recognize buck converters, but you guys know now because I've shown you here. And I think you'll be able to do that, and that'll help you a great deal. So how do we go about working on this? Well, we're going to power it up and we're going to check if we have sensible looking, because we don't know. I think we know this one is marked 5 volts down here, but if they're not marked, we're looking for sort of sensible voltages. We know what this is doing. We can check the voltage on the inductor. This will be the charge voltage. And if we don't have a charge voltage, we can have a look at the chip to see what it's doing. Specifically, does it have power input? Is it being enabled? So let's do that, and then let's see what we get to. Right, we're ready to go. There's some buttons, in fact they're marked on here, power. So I'll try run it from the battery. As I said, I don't know if there's any charge in it, and we'll try also with the charger attached, and we're going to have a look around the various things we know on here. So we'll switch this on. Light came on, so that's a bit of a sign. Okay, what do we have? Well, referring to my diagram, as we've just described, we need to find a good ground. That's the first thing. Probably the black lead from the battery, I'm guessing. But I am guessing. Let's see, if I've got that right, there should be a positive voltage here. Yeah, 12 volts. So, this coil. That appears not to be running. There's no voltage on it. Difficult that way, go this way. Press it again, green lights on now. So without accidentally pressing switches. This one is running, but it's actually low voltage. In fact, has it gone off? I think it's still powered up. No, it's gone off. Green light. Must have gone to standby, I think, then. 12 volts. This one. 5 volts. So that's what you'd expect there. I think that's actually coming from the coil itself. Yeah, 5 volts. This one down here. I think this goes into standby. Yeah, it does, but annoying, but still. About half a volt, so that's a bit low. I mean, I don't know what it should be, but I don't expect it to be that, if you know what I mean. Okay, so here. Yeah, it's just a very low voltage and dropping away. Thing's still on. Okay, so not sure about that one at the moment. Keep going. We have the one we're really interested up here. So there's 12 volts on this coil. 12 volts. Yeah, about 12 volts. So there's power there. But you'd think to charge the battery, it needs to be higher than that. So let's now connect the charger. To connect this, I'm going to have to connect the rear panel unless I just track it through. But it shouldn't be a problem doing it like this. Yeah, I can still work on that, I think. That'll probably make it a bit easier. We'll just test the charger, of course, to make sure it's working. Switch it on, of course. Yeah, 15 volts, that's fine, I think. So let's plug the charger in. Is anything happening on the lights? Well, the green light's on and flashing. Now, he did say, I think, that is the charging indicator, so it says it's charging. Let's have a look. So I would expect to have more voltage here. And I think this is where he said he didn't get any more voltage. Okay, so I've just put the multimeter in the inset window there where you can see it. Now, the power supply, or rather the charger, is off at the moment. So if I get on ground and I go to the coil, I'm seeing 11.2. So I have 11.2 volts. If I now switch the charger on and we have a quick look, if you can see it in there. Yeah, you can see it now. The green light is flashing, so that's the charging light. What do we have? You'd expect it to be more, yeah. And this is what Philip was saying, that it doesn't increase. So ground to the coil. And it's 11.2. So that basically tells me that this chip isn't running. Now, we have a data sheet, so let's have a look. We want to see two things. One, does this have V in, a supply voltage? And is the supply voltage within the specification of the data sheet? And two, does it have an enable? Is it switched on? Okay. So the input, 4.6 to 18 volts. Okay, and this is on pins 1 and 2. So this is your power adapter. So pin 1, pin 2 should have somewhere between 4.2 and 12.6. And considering this is effectively a 12 volt battery, I'd expect it to be a bit more. The power supply is 15 volts. So yeah, something like that on there. Okay. VBAT, well, we know really what we have on there, and it doesn't change. There's the inductor. So I was measuring on this inductor here. This will be just a low value resistor. Oh, current sense, CS there. Let me just zoom in a bit. So without even looking up the specification or rather the pinout for this, VBAT is the battery voltage, CS is current sense. So this resistor will be a very low value resistor. So effectively, what I measure here will be the same as here. So we know that VBAT is 11.2. So pin 1 and 2, what do we have? Should be 15. And what's on pin 5? That's what we're really interested in seeing. Okay, let's have a look. So here's our chip. Pin 1 and pin 2 are connected together, and that comes to this diode. We saw a diode on the data sheet. This MOSFET is in actual fact switching the supply voltage, yeah, through to this charger. So there's something else we can investigate, but for now, if we look on here, it's easy to get to. That is the voltage in. You can see it goes to there. Pin 5, 1, 2, 3, 4, 5. Well, easiest place to get to that one. Does it go to here or both? Let's have a look. Can we see? Yeah, now I tilt it, you can see it goes to both. So we can probe pin 5 on here or here. And that should be high to enable. Okay. So the voltage coming into the charger, that's here. 15. So the MOSFET must be switched on. We've got 15 volts coming into here. What's on the enable? Let's just get to it. It's very difficult for me to do this on screen, but I will. There. Put the ground on. 4.8. So that chip appears to be enabled. It appears to have power coming in, but it's not generating any boost voltage. Let me have a quick look at the data sheet so I can find any other reason why that may not be working. Here, by the way, we were just talking about the current sense resistors. They are here. Actual fact, let's just measure the voltage across there, because if there is any current flowing to the battery, which we're fairly sure there isn't, there wouldn't be any voltage here. If there is some voltage here, it may think some sort of over current for some reason. So 1 millivolts, so it's going to be small. I'm expecting there to be nothing here actually. So that's from here to the other end. Yeah, there's nothing across there, so there is no current. Let's have another look at that data sheet. Well, we do have some more information on here which may help. We have a little chart here. So it says that the chip is in shutdown mode if VCC is less than under voltage lockout, or VCC is less than VBAT. Now we know VCC is 15 and we know VBAT is about 11.2. Under voltage lockout, well, you could expect that to be less than 15, but we could actually have a look. So if we just go down the data sheet, yeah, under voltage lockout threshold is 4 volts. So we know VCC is above UVLO and we know it is above VBAT. So it should be in some sort of charge mode here, yeah. In fact, there is more information here that makes this easier for me to understand anyway than what I was reading in the other part. This, okay. So this is saying that normal charge cycle. A charge cycle begins when the voltage on the HVDD pin rises above UVLO threshold. Well, we know that's 4. Okay, so when pin 3 is above 4, it starts. If the BAT pin voltage is less than 68% of V float. Now this V float doesn't refer to a pin on the chip, but it says in this case the charger goes into trickle charge mode. Okay, supplies are about 1/10 of the program charging current. When the VBAT pin rises above 68%, it goes into constant current mode. So in either case, it will increase the VBAT to higher than what is in the battery to start charging it, and we know that VBAT doesn't change. Okay, so that's pretty much what we want to know. So as well as being enabled, we have to have this pin HVDD above 4 volts. So that's the other thing that we need to start the chip. Now if we look at that, HVDD is actually connected to the adapter input voltage. Okay, and we know the adapter is 15 volts if we look on our circuit. There, I have it switched off at the moment. The battery is disconnected, the charger is powered off, but you can see pin 3 doesn't connect directly to here, it goes off over that way somewhere. And if we go on to pin 3, just get on that, okay. That comes over this way to here and to here. Now we know this MOSFET is switched on because we have charge voltage here. So that VHDD must be more than 4 volts, which is UVLO. So this must be in a condition where it should start charging. It doesn't start charging, it just doesn't run. So although there could be some esoteric reason why that is not running, I think it's much more likely that this chip is faulty. But there's never any guarantees with this sort of thing. The question is then, to proceed, how easy are they to get these chips and how expensive are they? If they're cheap and easy to get, I think the answer is now change that, and then if it still doesn't work, well, we can get into some more complicated stuff. But I do feel there's a good chance that will fix it. Let's have a look. Okay, and we can get these quite inexpensively, about €3 with the shipping. I'd probably buy more than one if I'm going to buy one. I'll speak to the owner. I mean, we can buy 10 for that matter. So I'll get in touch with the guy. Some of these have sold, which usually tells me if people have bought them, then they do fail. That's a good way to look at it if you like as well. Okay, so the only disadvantage to that is it's saying, oh, December the 4th, December the 11th. So it's saying a couple of weeks. Okay, so Philip, that's what I think we should do next with your Bose speaker, because you say you've already replaced the battery with an original replacement. You've replaced the charger with an original charger. And based on the voltages we can see on the chip on our board, I think there's a very good chance that will fix it. But, you know, there's always the time that it doesn't, and then we'll have to get much more involved. The rest of you guys, what do you think? You got to this point in this, what would you do? Would you do the same as me and say, okay, the chips are not expensive, it won't take too long, let's change it? Or would you want to delve further? Is there anything else you would like to prove, or would you like to see me prove to show that there's even more likelihood it's this chip? Or do you think, given the trade-off between time spent and the likelihood of finding anything else more useful, is it worth it? Okay, hope you enjoyed. I hope you like the way we went through this one. That's a different technique I've not shown you before. It could be a bit overkill for this sort of thing, but it is very, very useful, especially with industrial electronics, things like the circuit board off the air conditioner I had, that sort of thing. This is a very good way to understand what you have. Okay, that's it for this one, guys. I look forward to seeing you all soon on another Learning Electronics Repair video. Ciao for now, guys.